Hi, this is team 20. We divided the task to 3 parts. I'm going to start the first part, and then my teammates will continue with the rest of the explanation. So the project is like a data set. We are using a data set called wine quality that contains information about red wine. For example, like how much sugar it has, or how acidic it is, or the alcohol level, and more. So at the end of each row, there is a score called quality, and this score tells us how good the wine is from 1 to 10. So I'm gonna explain what we did step by step. But our goal is to build a model that can predict this wine quality based on the other information. So the step 1 is importing the tools that we need, like NumPy for the numbers, like Pandas help with tables like Excel, and Matplotlib helps us draw graphs and so on. So we also write like np.random to make sure our results stay the same every time we run the code. And then we loaded the data, and data equals pd.read and so on. This opens the CSV file and puts it into a table called data. And then we looked at the first 5 rows to show us a sample of the data, like what we can see here. So each row is one wine sample. Each column is like acidity or sugar or like some features. And next step is looking at info about the data. So this tells us like how many columns and rows there are, or the type of each column, like number, text, and so on, or if any data is missing. And there's no missing values. Good news. And next is describing the data, and that gives us statistics for each column, like the average, minimum, maximum, and standard deviation, like how much value vary, and it helps to understand what kind of number we have, like alcohol percentage might go from 8% to 14%. And next is like the column names, like print data.columns. This shows us the names of all the columns in the data, like what we have in here, like fixed acidity, or what we can see in here. So, and that's it. That's my part. Elon will continue, and that's what I talked about. We looked at the wine data, and then looked at a few rows, checked the data types, some statistic, and we found that all data is completed and usable. Okay, thank you.
Hello, teacher. Here is the group assignment of the applied machine learning. We are the group 20, and my name is Yiling. And other 2 group members is the Yan and Fahimi. So for my part, I firstly splitting the data to the training, validation, and test sets. And it is about 60% of training, 20% of validation, and 20% of test. Then I firstly set the x and y regularly, and x is that for the all columns, except the quality, and the y is for the type variable, namely the one quality. And firstly, I split out the test sets 20%, then split the remaining data into training and validation sets. And from the remaining 80%, I allocated 25% as valutations, namely about 20% of the data. So yeah, you could see that I set the test size to the 0.2 and the random state as the 42. And for the chain test byte, I set the test size as 0.25 and the random state is the same. So we print the results. Means that data splice results. I will show this one later. Yeah, and then the next step I building and training a linear regression model, and then it's about iterate on the validation state. You could see and then print the results on here. And the next step is about using the SGD registers. SGD means that stochastic gradient descent, and with pipeline and high meter turning. The next is about define candidate rate for the learning rate parameters. Yeah, it's about I said the learning rate. I said the area of the learning rate is the element is about constant, optimal, and investigating. And then is we need to iterate the best SGD model on the validation set. For all the print result, I will show together later. And then for the final, it's about the polynomial regression model. And yeah, in this part, I try to use the follow to select the best model that is the highest R-squared score. Yeah. So you could see here is the result for the code I just said. It's on here. So based on the result, the data set was divided into 60% of training, 20% validation, and 20% test sets. This is the first thing I set on code. And then for the linear regression model, it achieved validation R-squared score of about you will see on here 0.28 with a mean squared error of the value about 0.45. And after tuning, the SGD requires slightly improved the performance with an R-squared of 0.28 and lower NSE of 0.45. And polynomial regression with degree 2 further improve the model, reaching the highest validation R-squared score of 0.3. However, increasing the degree to 3 or 4 led to server overfitting, with R-squared scores dropping to minus 4.96 and minus 96,000 respectively. Therefore, the degree 2 polynomial model offer the best trade of between the performance and complexity. And thank you so much. Here is my part. Thank you.
Hello, I'm going to talk about lasso part. So here we firstly create a pipeline to create the polynomial features and standardize it. Then apply for lasso regression. Then we use grade to find the best parameter for the lasso mode. Then we print this best parameter for the lasso mode. Then we print the different performance of validation set and test set. So then we can see here from the output we can see, so here we already choose the best parameter is 0.01, and here for mean squared error is around 0.44. so which means, so this is like is close to 0, it means better. So there has 0.44% mean squared error for it. Then we can check for coefficients. Then here most of them is close to 0 or is 0. It means lasso has successed the feature selection. And we can compare the R2 score. And here is 29%, here is 42%, which means this lasso mode actually in test set. So it's like the real performance is actually better than the validation set. So it can explain around 43% data with this model. So Lasso can help us to predict the performance of the project. Thank you very much.